In order to sketch the graph of a logarithm function, we're going to introduce a new strategy that we haven't used in graphing specified functions before. We did use this a long time ago when we were graphing just functions that we were given from tables and graphs and that sort of thing. But we haven't used this with a function that we have a formula for yet. And the strategy is, because we're graphing an inverse, instead of choosing values of x and plugging them in, we're going to choose values of y and find the corresponding values of x. See, on the graph of this function, we have y equals f of x is log 2 of x. So that means that x is 2 to the y. Right? Base stays the same. Argument and exponent switch places. So if we choose y to be negative 3, then x is 2 to the negative 3, or 1/8. If we choose y to be negative 2, then x is 2 to the negative 2, or 1/4. If we choose y to be negative 1, then x is 2 to the negative 1, that's a half. Then y is 0, 2 to the 0 is 1. Y is 1, 2 to the 1 is 2. Y is 2, 2 to the 2 is 4. Y is 3, 2 to the 3 is 8. Right, so by choosing the y values, we found the corresponding x values. And that gives us a bunch of pairs that we can plot in order to draw our graph. What's our graph going to look like? Notice we're only interested in positive values of x. We knew that because the domain of the logarithm only contains positive numbers. Our y values go from negative 3 to 3, so I'm maybe going to draw axes that look about like this. So my y-axis is all the way over at the left. My x-axis is kind of across the middle, because I'm only interested in positive x values, but I'm interested in both positive and negative y values. And then, these points are easy to plot. So I've got 1, 0, that's right here. 2, 1, that's here. 4, 2, and 8, 3. And then these points are a little bit harder to plot, but I can at least estimate them. So I've got 1/2, negative 1. A half is about there. 1/4, negative 2. And then an 1/8 is real small, so 1/8, negative 3 looks something like that. And now we see that we're getting real close to the y-axis. These numbers are just going to keep getting smaller and smaller, but never quite get to 0. To indicate that, we're going to draw an asymptote again, but this time a vertical one that's in the same place as the y-axis. And then we fill this in with a smooth curve. We're getting real close to the axis down here. And over here, we're going to keep getting bigger, but real slowly. And there's our graph of a log function. And that should look familiar. It looks like an exponential, except it's flipped across a diagonal line. It's flipped across this line. Think about the way an exponential function looks. It's a lot like that, except it's going upward really fast instead of going to the right really fast and upward slowly. And that's something that we've seen before. We already knew that that was what happens when we graph an inverse. because we're exchanging our x and y coordinates. We already knew, but we can see this on the graph now, that the domain is all positive numbers. We can also see on the graph that the range is all real numbers. And we can also describe the end behavior, except that what we mean by end here is a little bit different. One end of this graph is at x equals 0. So we see that when x gets very, very big, f of x will get as big as we like eventually. It gets big very slowly, but it does still get up to any number we like. And then the other end is at 0. When x gets close to 0, f of x, that's when f of x goes to negative infinity. So f of x gets as negative as we'd like when x gets very, very close to 0. In this graph, we see a vertical asymptote. As now x rather than y can get close to 0, but never reach it. Right, x can be as close to 0 as we'd like. The log of a very, very small positive number is going to be a very, very big negative number. In this graph, the asymptote is the vertical line x equals 0. Remember, x equals a number gives us a vertical line. And we'll see this same general shape as long as our base is greater than 1. Just like with the exponential, the log has a somewhat different general shape if the base is between 0 and 1. And that's what we'll see in the next video.